let's make a start then. Thanks very much again for attending today's webinar. We hope you find it interesting. We'll be focusing on reverse engineering. After the session, we will make a trial available. So if you would like to try the solution out, please do let us know. Just in terms of brief introductions, I'm Rob Shropshire and I look after the sales and marketing side of Origin. So I'll be running the session today and will be your point of contact moving forward if you want to chat with us further. I won't be doing a lot of the talking today apart from a short introduction into the setting some context in terms of the challenges our customers face and how we hopefully help to solve them. And then I'll pass over to Tim Dukes, who is on the call as well, giving you a wave, who is focused on the training and support for all of our customers and also shaping our product strategy. So he'll take you through a more detailed demonstration after the introduction. Tim, just make sure you're muted. If anyone's not muted, just to stop the feedback. Thank you. So just in terms of the agenda, we'll start off with a brief background in terms of who Origin are. I then just want to set some context in terms of the types of challenges we see our clients face in terms of reverse engineering prior to implementing our solution. And then we'll, as I say, get right into the demonstration and show you a few different reverse engineering workflows along the way. We do prefer this session's interactive. There will be a few polls as we go through, so we will ask you a few questions anyway. Be really grateful if you could answer those for us. But as we're going through the session, if you've got any questions, make sure you ask them. We'll get to them at the end. We don't want this session to be boring. The actual content, it'll probably only take us up to about 2:40-ish, so we'll have plenty of that hour left. So we'd love to answer some questions for you. So in terms of Origin, brief background, we're UK based and we support over 200 manufacturing and design companies across the UK and Ireland. We typically focus on tools that help design and manufacturing engineers. So that includes basic CAD, but it also includes simulation. So tools for FEA, CFD and thermal analysis. But we also help with the simulation of manufacturing methods as well in terms of injection molding, casting and metal forming. The products we'll be showcasing today are from Ansys, and we're really proud to be one of their official partners. We, as well as providing the software, we provide that training in order to get you up and running, but also support thereafter in terms of dealing with any issues. All of our solutions are relatively low initial investment, so we like to think that a business of any scale can get on board and use them. And the solutions take a day of training, so hopefully the time to value is pretty quick. So just in terms of, I guess, the types of reverse engineering workflows and the items that we think we're good at, 2D to 3D. So we're still getting a number of companies that are getting their drawings in 2D formats, and their challenge is to try and be able to convert that into a 3D model, make some modifications without necessarily having to reinvent the wheel. So we'll show you an example of that. Of course, more commonly now, we're starting to use 3D printing processes. Lots of businesses might have scanners, so actually you're taking scans of old parts and then getting some sort of faceted data format into your CAD system, such as an STL file, which is probably the most common one. And then you're trying to reverse engineer from that data, perhaps turn it back into a solid. So we'll be showing some tools on how we can hopefully support that and make dealing with faceted data a little bit more easy for you. Sometimes you might already have a 3D model. It might just be a really old one in an old CAD format, or perhaps in a different CAD package that you don't actually have a license for. So it becomes quite simple instead of just wanting to be able to bring that in, no matter what format is, and to be able to make some quick modifications perhaps to that old part. Some people on the call today will be dealing with more prismatic shapes. Some of you will be dealing with organic shapes, particularly if you're perhaps doing stuff around, you know, the medical sector, for example. So we do have tools, hopefully, which allow you to cater for those two different types of shapes or parts that you might be working with. So we think we've got a fairly robust solution. You know, in our experience, that there are a few challenges within reverse engineering. I'm sure some of you on the call today will probably have experienced some of these. And what it means is you spend more time trying to reverse engineer, so you just end up actually just drawing it from scratch because it's just too painful to work with what you've got. You know, we'd imagine that if your CAD system is not capable of being able to bring something in and work with it and leads you to having to redraw it completely, then that's probably not a good sign. And hopefully you'll see some stuff in here that might make your life a little bit easier. The first issue is quite simple. You get something in you know, a CATIA format or a SolidWorks format or an AutoCAD format, IGES step, and your CAD system just doesn't like to play with that type of data. So you can't really bring that into your system well and start working directly with that data. So that's the first issue we find. The second is that although STL files are great and it allows you to take a quick scan of a part, when you bring that STL file into your CAD system, there's often imperfections. There might be some gaps or sharps in there which are really preventing you from actually being able to take that faceted STL data and actually turn it into a solid to allow you to better work with it and start making modifications to the geometry. The third challenge, most software will allow you to import STL files, but we do hear of reports of limits on the element size or limits on the size of data that you can actually bring into your CAD system. So maybe it just takes you know, an absolute age to import, or maybe you've just got those limits, which means you have to sort of cut and slice the data and import things in gradually or separately, which can be a real pain. So hopefully we can help with that. The other challenge we typically hear about is when you're not the author of a model, it's sometimes difficult to understand what's going on in that, especially if it's quite a complex assembly. And the problem with parametric modelers a lot of the time is that you typically make those changes on that structure tree. So you do need to understand what's going on before you can start making modifications. And hopefully we'll show you an alternative way of working today. Again, because of this concept of working from a structure tree, sometimes even making the changes, even making the smallest changes can be quite time consuming. So hopefully you'll see that our direct modeler approach makes things a little bit easier for you, particularly in terms of reverse engineering. So in terms of the ideal workflow, or what we sort of advocate with our customers, is that number one, the product that you use for doing reverse engineering should not be fussy about what you're importing. So with our solution, you know, AutoCAD step, IGES, various versions of CATIA, SolidWorks, you know, you name it, STL files, you can bring all of that data in, and you can search the features from within SpaceClaim. So it's very easy to find features and to work with that data. Because it is a direct modeler, when it comes to actually modifying that data and changing it, you're not really having to understand the structure tree and to find out where everything is. What you see is what you get, so you can look at the model and make changes immediately. Now, of course, parametric modelers, they have their place. They're very good when it comes to that detailed technical design, where you're sort of designing something from the ground up. But actually, if we're reverse engineering, if we're just trying to do stuff quickly, then actually a direct modeler has its place. We also believe that it is kind of useful if you're making changes to a previous part. it's nice to actually validate that what you're doing is going to it's going to perform in the real world as you'd expect it to. So what we are able to do is actually to run simulation as we go. The unique thing here is that the simulations run off your graphics card. So the simulation is pretty much instant for you. So as you're moving through and making changes, you can perhaps do a really fast FEA analysis to check factor of safety, for example, in terms of the changes that you're making. So having that integrated idea of iterative design, being able to work with the data directly, coupling that with simulation, we think is really powerful. Now we have put a poll on the screen, which I'll just pause briefly, just in terms of what you're currently using. So do fill that out if you can. It's always useful for us to understand what you're currently using. So that's where we sort of hope you'll get to in terms of reverse engineering, and that's what we'll be hopefully showing and focusing on today. Just before I get into that, just as a final slide before we get into it, it's important that you understand that sort of as we go through this presentation, you will sort of see two interfaces really. So we have a product called Ansys SpaceClaim, which is a full blown drawing package with everything that you would expect. So it allows you to do your drawing sheets. It's got support for sheet metal. It's got support for 3D printing, reverse engineering, and then we've also got a product called Ansys Discovery, which is more of a sort of integrated modeler and simulation tool. So it's got a subset, if you like, of the CAD functionality that's available in SpaceClaim, but it does give you all of those physics, structural, fluid, thermal, and indeed topology optimization. So there will be some people on the call today that actually just say, I'm just interested in CAD, that's all I care about, in which case you might want to look into SpaceClaim. But increasingly there are lots of customers that are now wanting to start to blend simulation into that, so you can look at Discovery. The important thing here is that if you go for Discovery, you get that full license of SpaceClaim. So that's just in terms of when you see two packages, that's what we're talking about, and we're happy to answer more questions at the end if you've got them around that. So we're just about to pass over to the video. Tim, if you just mind putting you've already put it on. So yeah, just interested to know whether you currently use simulation. I think quite a few of you are, which is a good thing. Yeah, more people using it than not. So that's good to hear. So what we're going to do now, I will pass over to Tim just for the purpose of the video and the demo that we'll be taking you through today. We're going to turn off our cameras just so you can sort of see it a bit better. So with that, I'll just turn my camera off and over to you, Tim.
Thanks for the introduction, Rob, and again thank you everyone for joining. Over the next 30 to 40 minutes, we'll be taking you through a number of reverse engineering examples in the Ansys Discovery product portfolio. This will start in the Ansys SpaceClaim software, which we can see now, and we will then move into the Ansys Discovery software. We will be looking at a few different examples of reverse engineering, from prismatic and organic to 2D to 3D conversion, surface wrapping, a bit of sub-D modeling from STL data, to actually running a simulation on actual faceted data, which is now possible in Ansys Discovery. So first of all, we're going to open up an STL file, probably the most common faceted data format, but we can open up other ones such as OBJ, AMF, and VRML, I think is another one. So we're going to open up an STL file. This is a great example because it shows off a few different tool sets of prismatic and organic reverse engineering. We can see these areas are fairly prismatic, and this obviously pipe section is quite organic. It's sort of doubly curved. So first things first, I do notice that we've obviously got some errors in the file. We've got some holes. So we do have a tab called the Facets tab that's dedicated to basically working with faceted data. We've got a number of tools such as actually checking the facets, and this basically will tell you if there's any errors. We can clearly see. We've got auto fix. We've got shrink wrap, holes, intersections. So the tool that I'm going to be using is the actual holes tool. On the left hand side, we can see that we can either patch or cap. So for this one, I'm going to patch. Hopefully it'll match the curvature. For the other one, if it's a flat surface, you might want to say cap. So that's just quickly fixing those holes. We can check our facets, and hopefully we'll see that there's no problems now. This tab is great for working with faceted data. If you are in the 3D printing world, it's great for prepping models for 3D printing. And you can also work in like a hybrid setting of actually working with normal CAD data and STL data or faceted data in the same window, and we can merge, subtract, combine, and play around with both sets of data in the same window. So to start with, sometimes when you are bringing in scan data or STL data, sometimes the first step is to actually orientate the data. This model is actually nicely orientated to the origin, but if it wasn't, we could use the Tools tab. We could go into the Orient Facets tool, and then you would be finding areas that you want to align with things like the Z-axis. And once you've aligned two axes, your model will be aligned. So that's a tool that we can use, and we'll be looking at some of these other tools shortly. But to jump straight into the reverse engineering side of things, we're going to basically select on two axes because it's nicely aligned, and I'm actually going to create a work plane. So I'm going to focus on this area first, and I'm going to use my move tool, and I'm just going to manually move this move tool into the model so I can extract some data. So I'm going to go into a sketch mode. From here, I can basically extract the curve data that we can see here. So if you can see, just about green is are lines, blue are arcs. So we can extract this and we can turn it into curves. So the easiest way to do that is just to box select it, do a copy and paste. You can also use your Windows shortcuts, Control C, Control V. And we can now see that we've actually got curve data that we can start to refine if we wish. We can see some of it isn't as clean as we may want it, so we've got tools to obviously start to constrain and modify our sketches. Another thing that we can do is use this Fit Curves tool. At the moment, this profile is made up of 22 curves. I could use this Fit Curves tool here. On the left hand side, we've got a tolerance. I'm trying to fit lines, arcs, and create the tangency. And we can see here, I've gone from 22 curves to 8. So just refining the data using this repair tools. Again, I'm going to use it here. I can increase my tolerance. So you can see I can increase my tolerance to suit. I'll do the same for these two. And now I've got nice circles rather than multiple curves. So I've just cleaned up the data. Obviously we can then go in and constrain the curves. We can actually start to dimension these areas and make them more uniform and make faces parallel, etc. I won't focus on that too much right now because we want to sort of go through as much as possible. So I'm going to end the sketch editing, and you can see now we've got a surface profile there. So the curves have been turned into a surface. Bringing back my STL, I can now select on this surface using the up to tool. I'm just going to snap it up to the STL data that's there to create a solid. So I'm going to extrude it up to the STL data, and we can now see that nicely overlays with that data. So the next thing to do is to do the similar sort of thing on the opposite side. So to do this, first of all, I'm going to create a plane. And to create a plane, I'm going to double click, and when you double click on a faceted data, it picks up on a best fit of a number of them. But we do get this slider bar where we can increase or decrease your selection. So so now I've got a number of facets selected, as you can see here, and I can then fit a best fit plane to those areas. So now I've got a best fit plane there. Again, I'm going to use my move tool just to move this into the data. And then we're going to go into a sketch mode again. So I'm going to show you a slightly different technique here where I'm extracting the curves and then creating the data. So in this example, rather than extracting the whole curves, all I'm going to do is extract the green line data. So I'm selecting on those four lines. I'm doing a copy and paste. And again, we can see the curve data that's been extracted. I'm then going to use the create corner tool just to obviously join these areas up. And then we can obviously start to use our constraints. So you might want to use parallel constraints and make these areas parallel. And then bringing the faceted data back, I can then use the create corner tool, create rounded corner, and I'm going to start to create a rounded corner, obviously using the data there as a guide. So we can see here we're looking at probably 10 to 9.5, and we can start to create these rounded corners. So we can see here we're probably looking at around 40, and we'll do the same on the other side. So this is a slightly different way of doing it. Obviously, this is probably the way I'd do it realistically, because you're getting a lot more control. Rather than, again, spend loads of time here on these areas, I'm just going to just copy and paste them and do the repair curves. But obviously, we can constrain things and align things and all that sort of stuff. But we're not going to spend too much time doing that in this video, but just be aware we can do that. So again, we've got another surface now, which we can use the extrude tool to start to pull to the shape of the part. So now we've got our two profiles. The next step is to actually join these areas up. So first of all, I'm going to hide the facet data, and this face here, obviously there won't be a face here in the actual data, so I'm actually going to right click on it and delete it. This brings this back to surface data, and then I'm going to just resize these areas, and I'm going to eyeball it here. Please be aware you can be a bit more precise than I'm being. We're doing this for sort of speed at the moment, and obviously this surface here we need to bring out to there, and the same on this surface, this edge here. We can then bring this out to around there. So we've created our two surfaces. Now, how do we join these up? So the way that we're going to join these up is we're going to join them up via planes. So I'm going to create a mid plane just in the middle. Again, just sort of eyeball it in the middle just to give me a bit of a guide when I'm joining these up. Now I'm going to go into the Tools tab, and we're going to be using our Skin Surface tool. So this is one of a number of tools that we can use to work with faceted data. And I'm going to start with the outer surface. So I'm going to click this edge here, hold Control and click this edge, make sure I'm going to the outside, and then I'm going to click this edge here. This will give me a bit of a preview, hit the tick box, and this should create me a surface, which we'll look at in a second. And then I'm going to do the same thing now for the inside, hit the tick box, and you can see straight away I've now got a solid model that I can now extract, save out as any solid format. So we can see the two side by side. Let's just create a copy of this this faceted data, and we can see that nicely overlaying with that. So that's a very quick example in SpaceClaim of organic and prismatic together, showing you some examples of reverse engineering in SpaceClaim. We'll now look at a 2D to 3D within SpaceClaim, and then we'll move into Discovery. In this next demo, we're going to be looking at how we can actually reverse engineer 2D data into 3D data. So SpaceClaim and Ansys Discovery are great programs at taking 2D data and turning it back into 3D data. So in this example, we've imported a 2D DXF. We can see that it's 2D. So to take this back into 3D, we just need to follow a few simple steps. The first steps is to clear a lot of the noise, is to actually just extract the views that we're interested in. So to do that, I'm just going to just hold a Control, copy, box select some of the views that we're interested in, and then we're going to do a copy. I'm going to open a new design. I'm going to use the Windows shortcut Control N, and then I'm going to do a paste. So this pastes those views into a new design, just separates all the extra noise, and then we can end the sketch editing. This will take us into a 3D mode, and now we can see that those curves, as long as they're closed curves, have become surfaces. So to create the 3D model, I'm going to start reorientating a few of these views. So the first one I'm going to do is this one here, and I'm going to just rotate it 180 degrees, and I can type 180. And then I'm going to rotate it also 90 degrees, or 270. In this instance, it doesn't matter too much. Once I've reorientated to this position, I'm then going to actually move my move tool onto the center of this bottom line here, or its bottom edge. Then we can snap those surfaces I've got selected there up to this point here, and that'll align it perfectly with that location. Then I'm going to use my pull tool to extrude this face, and again I'm going to use this up to tool to reference the end of the part. I can then use my extrude tool again, and this time I'm going to extrude this middle section, or this middle view, and I'm going to extrude it in both ways, and I'm making sure that I don't merge it into the existing solid. Then I can use my combine tool, which you may know as the Boolean tool, and I'm going to select this as my target, this is my cutter, and this allows me just to remove the bits that I'm not interested in anymore. So now I've got my profile. The final thing to do is to select this view here, and we're going to rotate this 90 degrees. So I'm just going to double click, and that will just rotate it 90 degrees. These three areas here are cut out, so I'm going to turn those into a surface that I can then use to slice through the solid at the top. So to do this, I'm going to copy and paste the edges, so Control C, Control V. Use the fill tool, that becomes a surface that I can then use to extrude as a cut through this model, and we can see that cut through there. Just to clean up our model, let's get rid of all this noise and excess surfaces. We don't need any more. Any excess curves we're not interested in. So now we've got our 3D solid model. In this instance, it actually is a sheet metal part. We do have a sheet metal tab in SpaceClaim. We can convert this quickly into a sheet metal part and then actually unfold for manufacture if needed. So that's a short video of how we can reverse engineer 2D data back into 3D data. So we've now moved over to Ansys Discovery. In this software, we'll be looking at a few more reverse engineering techniques, and then we'll actually be looking at how we can run simulations on faceted data. So Ansys Discovery is a very similar interface to Ansys SpaceClaim. Again, the same import options will be in this software. So I've imported another STL file. In this software, you can see that you have a lot of similar tabs. Color scheme is slightly different, but in this software we have the additional functionality of subdivision surfacing, which we'll show a faceted example shortly. And then we've also got the option to do simulations. In here we can do structural simulations, fluid simulations, thermal, topology optimization. We can also do modal, and we can also do some multiphysics as well. So in this example, I've imported an STL file. We can see it's again an STL file. This is an example of more organic reverse engineering. So with this model, you wouldn't want to build up prismatically over the model. So for this one, what we go to is the Facets tab. Here we've got our reverse engineering tools in this section, and this one I literally just want to do an auto skin. So I click the auto skin tool, click on my faceted file, and hit the tick box. If the STL is of good quality, you'll get a surface. At the moment, I'm highlighting some errors, so we can see where these errors are. And if I just go into select mode, I'll zoom in on the model. The STL at the moment may not be brilliant, so we can see that there's some strange areas here where obviously the STL is sort of folding in on itself, and might cause some sharps. So it's struggling. The tool's struggling to work, but that doesn't matter because we've got some great tools, obviously in our Facets tab, to actually be able to fix that. Some of them are the auto fix tools, so I can go through those. However, we also have the shrink wrap tool. Shrink wrap is great for if you've got an assembly and you wanted to potentially print it as just like one object, you could shrink wrap the assembly into one object, but you can also use it to sort of clean up or remesh your part. So using the shrink wrap tool here, you can set your sizing. I'm going to preserve the features, and we can all set all our thresholds and stuff. We can then click on our part and hit the complete tool, and you can now see that we've just remeshed our part, and we can see our triangles are more uniform, and hopefully that will have removed that error that we saw previously. So now we can go back into the auto skin tool, click on our STL, hit the tick box, and within a few seconds we should have a surface body, a solid body, that can be exported out as any solid format that we wish. So we can see now we've got a solid body made up of a number of surfaces. It's obviously matched to the STL that we had. We can see here we've got our solid body, our original STL, which we can turn on just to sort of overlay it. So we can see it matching to the STL pretty well. If we look in our display tab, we can just show that these are tangent surfaces, so they are all tangent surfaces. So that's just a quick example of more organic reverse engineering, where we can auto skin models to get back to a solid. Demo, we're going to be looking at sub-D modeling and how you can use it again with faceted data to make modifications. So we've imported this is actually a bike helmet. Hopefully you can see that. This obviously is faceted data. We can see the triangles that make up this part. So if we go into our subdivision surface tab, we've got a tool here that allows you to convert facets into actually sub-D surfaces, which then potentially are easy to modify. So if I click this tool here, click on my part, and then we can set a tolerance. I'm just going to set that to 5 mil so it goes a bit quicker, but I'm going to then hit the tick box, and this will convert this faceted model into subdivisions surfaces that then we can do some modification on. So once we have converted our facets to sub-D, this is what it will look like. It will look something similar to this. So what it's done is obviously it's converted the facets, obviously it's subdivided it into a number of surfaces, and in the sub-D surfacing tab we're able to modify technically the cage code, which allows us to actually modify the geometry. Just to view that cage code, the cage that we're actually modifying, we just view both, and we can sort of see this behind the surfacing, and that's obviously what you modify, and by doing that the surfaces change. I like to just turn that off. So in this tab we can also create geometry, so just some shapes that we can create into sub-D. We can also convert normal CAD geometry into sub-D and start to modify it. But obviously we've gone from an STL model to a subdivision surfacing, so now we can make some modifications that potentially were quite difficult previously. So for example, I might want to modify the angle of this area here. So I'm going to just sort of like box select this area. So I've just selected this area here. We can always increase our selection, add more facets, that sort of thing, if we wish. So I'm going to select that area there, and I'm going to use my move tool, and we're modifying obviously the cage behind it, and then we can see how we can literally use our move tool and start to modify the geometry. Obviously I can type in values there, but we can see how we've made that change. Obviously that sort of change would be very, very difficult to make if it was in a faceted data format. Other things that we can do in this subdivision mode, maybe I want some more of these ribs in areas. Again, in the facets mode that'd be quite difficult, but here we can make bridges between bits of data. So I'm selecting 2 bits of data, and I'm using this tool here called bridge, and we can see I've just very quickly created another rib just to show you that again. On other bits of data, let's just select on potentially these 2 areas, and I might want to bridge it to there, and click that tool there, and we can start to bridge data. So you can create holes in subdivisions by basically doing the same thing where we click the bridge tool and that would punch a hole through if I had two on the other side. So you can do that sort of thing as well. Also, if you actually wanted a bit more control, you might want to actually split the surfaces into numerous more, so it gives you a bit more control. So you can see now I've actually just used the split tool to actually convert this to basically double the amount of surfaces I have to give me more control potentially in modelling. So that's just a short example on how we can go from scan data to surface data through using subdivision surfacing. Great for sort of more organic type shapes. Now, once we've done this, we'll be looking at some simulation on STL data. So our next demos in Ansys Discovery are going to revolve around actually running simulations on faceted data. So this is a good one to start with because we've just done the subdivision modelling on this, but we're going to actually remove the sub-D modelling. Let's just delete this and take it back to the actual faceted data. So what we can do in Discovery is actually run simulations on faceted data, and we're going to be going through a few examples. We're going to show an external flow in this instance, and then we're going to show another example where we do a structural and then an internal fluid flow on faceted data, which is unusual. So for this example, as a bike helmet, you might be interested in obviously the flow characteristics over the dynamics over the surfaces. So we can set up an external flow very quickly in Discovery. We can say here external flow. Where's the fluid flow coming from? In this instance, it'll be air. And where's the ground plane? And I'll say that's my ground plane. Once that's done, we can then modify our properties in the left-hand side. So let's, for example, this would be air. You can also create your own materials. We've got access to material databases if the materials aren't there as standard. This is my ground plane. Again, we can modify all this fluid volume here. We can move it using just the our geometry modification tools, and then we can set up our velocity. So in this instance, you might be interested in you can set any units we wish. We might be going 10 miles an hour, for example. And we won't be interested in the fluid flow over that helmet at that speed. And then we can hit the solve button, and instantly we're going to start to get some results. I might be looking at vectors over that helmet. We can look at isosurface. We can look at streamlines, particles, and we can also look at a direction field. So if I just rotate that direction field, we can start to get a better idea of what's happening. So we can start to see how the air flows over the helmet. Obviously we have got holes in, so we are going to be getting turbulent flow. We could have obviously put a bit of geometry to maybe represent the head. We can start to see we're getting a little bit of weight flow, but we're looking at how the obviously the air flows over that helmet. For this sort of helmet, maybe it's more mountain biking. You might be more interested in like stress testing on it, but obviously for any sort of bike helmet that's to do with speed, obviously aerodynamics is very important. So this is the sort of thing that you can do on any faceted data in Discovery. So now we'll be looking at a structural example. So now we've looked at an external fluid flow example, we'll be looking at a internal fluid flow and our structural example on, again, faceted data. So going back to this this manifold that we had previously looked at reverse engineering, we'll quickly look now how we can actually set up simulations on faceted data again. So to do this, I'm going to set up some faceted regions. So I'm doing this by basically like selecting regions that I wish to be used in the simulation. So the regions that I'm first going to set up are the areas that may be supported. So we can see here, right click and add as a faceted region. And this just means, one, it's going to be much easier to select, and two, that they can be used to actually add structural physics to them. So these can be added as supports. I'm presuming that these potentially will be bolted, and we can now add those as supports. I'm also going to say this internal region here, and again I'm using my slider bar to sort of select that area. I'm going to add that as a faceted region, and we're going to potentially add like a pressure to that area. So we've got our region sort of set up now. The next step is to start our simulation. So as I said, these first areas are going to be supported, and we are doing a structural simulation on this part to start with. So I'm going to say they're fixed. So I just need to go through the regions that I've just created and make these fixed. The next step is to add a pressure. I'm going to add a pressure to this area here. We can choose different values, set different units. I'm going to just make up something here and type in 10 megapascals. Once we've done that, we're good to go for our simulation. In the left hand side, it's presuming it's structural steel. We've got a pressure, we've got our supports. Because we're using the graphics card, we're able to actually run these simulations, and we're going to get results very, very quickly. So we hit the solve button, and within a few seconds we are getting results. So at the moment we're just looking at displacement. We can actually visualize that displacement and animate it. That is over exaggerated. If I say this, I can scale that down, and obviously not much displacement, 0.02 of a mil. You might be interested in like high areas of stress on the model. We can then analyze the model and look for high areas of stress. As a designer, you might be interested in factor of safety, depending on where this is meant to be used. Those are things that we can start to look for, but you can see that we can actually do that on faceted data, which is fairly unusual. So that's a very, very quick structural example. I'll now show you a fluid example. We'll use it on the same part. Obviously, potentially maybe fluid would be flowing through this area. So we first need to extract our fluid volume. So because it's not a CAD model, the volume may be a little bit more difficult to extract, but this is basically going to be my fluid volume. So I'm going to select on this that I've already got as a faceted region. Obviously we saw how we can create a faceted region, and I'm going to just do a simple copy and paste. So once I've copied and pasted this is the area, the facets that I've now got. So this will become my fluid volume. I'm going to trim this with a few like sort of planes to sort of neaten it up, but you can hopefully see what I'm doing here. And again, we're going to be using some of our tools that we looked at within the reverse engineering examples. So into this facets tab here, I'm going to use the actual split tool. I'm going to say no cap, and we can see how we can just split these areas off, get rid of that rough sort of data, which I can then just right click and delete if I wish to get rid of it. Obviously it's not a solid, so we can't watertight solid, so obviously we can't get it as a fluid volume now, but I can just use my auto fix tool just to very quickly cap those ends off. If you wish, you could also use your move tools to overextend these things, so we can use this sort of move tools and actually sort of directly modify potentially faceted data to overextend these areas. Now the next thing to do is set up my facet regions again. So I'm just saying that's a facet region, maybe that's my inlet, and maybe this is my outlet. So once I've done that, I'm now going to set up a fluid flow simulation. Let's just hide these planes, and this is my inlet, so I'm specifying a fluid flow this time. This is the inlet. Again, we can do a velocity, mass flow, pressure, swirling flow, but I'm going to just do, just for the purpose of the demonstration, a 1 meter per second inlet, and this will be my outlet. I'm going to have that as 0 pressure, and we then should be able to set up our solution. So straight away now we're getting results again very, very instantly. The solution is still converging, but we are visualizing, getting results. So we're looking at vectors at the moment, so we can obviously see the direction of the flow. We can then start to look at contours, which we can change to bodies, faces. We can look at particles, and if I zoom in, we can see what's happening. And we can also look at flow as well. So that's just, again, a very quick example of a fluid flow example taken from an actual STL model, which hopefully shows the power of discovery and working with this sort of data.
Great, thank you very much. Hopefully everyone enjoyed that or got something out of it. I'm just going to wrap up briefly. I'll just share my screen one last time. Hopefully everyone's seeing that. So look, I mean, people on the call, may well be using, probably will be using a CAD product already, which might not be what we've shown you today. I think the way that we approach our conversations with customers is, it's all about using the right tool for the right job. I think every CAD product will have pros and cons. I think what we've got is something that we think is pretty affordable and is very good when it comes to things like concept design, things like reverse engineering and working with customer data, making those quick changes. Also, we gave a little teaser of the sheet metal side as well, which it's very strong at. So if there's people on the call that are focused on those areas, you might want to talk to us. Lots of organizations that we work with may well have a variety of different CAD tools which they'll use for different jobs. So sometimes SpaceClaim is the only tool that they use. Sometimes it's part of a variety of tools, but they'll use SpaceClaim because it does stuff a lot quicker than perhaps some of the other packages that they've got do. The other thing that we talked about, of course, was simulation. We'd like to think that, again, for its affordability, the amount of features that are being packed into the product, there's a lot coming. Discovery is the newer product, if you like. So it's fair to say that, a lot of the features are going from SpaceClaim into Discovery, and there's an aggressive roadmap going into Discovery. So, you will see more and more features coming into that product. But I think for a designer, there's nothing on the market that is as easy to use and as quick in terms of getting those simulation results. Tim's gonna pop up a poll for everyone now, I think, or I will actually. Let me just do it quickly, which is just if you do want something else from us. I mean, as I said, with all of our with any technology, proof is in the pudding. So we always advise you go and try this stuff, and we're very happy to make trials available to allow you to go ahead and test the technology and see if it would work for your business. We can support you with that as well. We're very happy to give a trial, but doing some sort of demonstration and working with your data, perhaps showing you the workflow that we take, can be useful in terms of getting the most out of your trial. And some people here will be sort of crying out for the technology, but struggle to justify it with your boss or management team. So we certainly have cases, both in terms of the time that's being saved through something simple as reverse engineering, or sometimes if it's simulation, it's looking at the value to the business, not just in terms of increasing the quality and speeding up product development, but an area that we're seeing a lot is actually using it for marketing purposes. If you're coming to the table with a simulation and being able to show your customers how things are going to behave in the real world, they're much more likely to pick you over a competitor. We've also seen lots of organizations increase their service offerings to their customers. So a lot of the time we're seeing customers that have clients that are coming to them for simulation. They don't quite have the technology in place, so they ship it out to someone else. So actually some of our clients are saying, well, hold on a minute, we'll take some of that business, we'll bring that in-house. So that's something that we can talk about as well. So with that, that's all we've got. Hopefully we've got some questions. Tim, I can see you've answered some of them here. There's one from Annabelle. Tim, if you can see that, with the simulations, do you get the same results later?
So you will be able to get graphs and stuff. It won't be exactly the same as Workbench because it is a subset. You can export reports and graphs and all that sort of things. but they probably won't be exactly the same as you might get in Workbench through, for example, like Fluent or something. So there is a slight difference, but in theory, you can get a lot of the same results out. It might just be like in a slightly different workflow. I can also see another question regarding fluids for mold flow. Discovery doesn't really simulate mold flow. It can obviously simulate the flow of material, but obviously it doesn't then simulate the solidification or freezing of that material. If you are interested in mold flow, we do have other software available that actually is specific to mold flow simulation and solidification. Another question regarding split lines for tooling. Yes, SpaceClaim and Discovery can both do that. We've got a really powerful draft tool in the measure key where you can see where those 0-degree split lines are. We can actually do this in STL data as well, and then you can actually extract those split lines from either CAD data or STL models. So yeah.
Thanks, Tim. Yeah, and as I said, if you are interested specifically in the mold flow analysis, then let us know. We can look into that. So if there's any more questions, we'll stay on for another minute or two. This recording will be sent automatically to you, so you'll get a full copy of this. So if you've got colleagues that you think might have liked to watch it but didn't have the time, then you'll get the recording and you can send it out to them. I'll just flash my details up, both of our details. If you've got any questions, drop us an email, give us a call. I mean, I will get in touch with all of you just to say, a bit of a thank you for attending. Perhaps give us some feedback in terms of what we might be able to improve for the next webinar. So I will be in touch. But if you've got any immediate questions, then feel free to drop them in an email to us or call us directly.